Learning algorithms is not easy. Well, I'm not saying it's very difficult, but it's not a completely easy task. So a natural question to ask is, what do I gain? What do you really gain as you go along this journey? And you can think of 5 different pathways of this particular journey. One is that it would help to sharpen your analytical skills as you look at so the body of knowledge of algorithms through the lens of mathematical analysis, and you're looking at the design and analysis of algorithms, then quite naturally, it would sort of sharpen your analytical skills. Another pathway would be your sort of computational skills, which would get sharpened. You would become a better programmer as you implement algorithms, as you get a better sense of where the theory and the practice come together. Then your skills as a programmer will naturally get better. The third is think along the lines of sort of algorithmic thinking, and sort of simply put, this means your ability to deconstruct large complex problems into smaller, simpler problems will get better and better over time. A fourth pathway is clear sort of career progression, be it if you're interested in technology jobs, or if you're actually interested in AI jobs, or even if you're sitting for competitive examinations which allow you to work towards higher studies, then algorithms usually have a very important role to play in a lot of these sort of examinations and placements. And finally, as we're going through this journey, we might as well take the opportunity to sort of delve into some of the great minds of computer science. When you have some body of knowledge which has reached an undergraduate level, or even as a textbook at a graduate level, it's been many, many years, if not decades, of research and struggle of certain people who then eventually make progress, which then finally finds its way into a textbook. So it'll be nice, to see parts of their journey as well, and not just be worried about here's an algorithm and this is how it works, but when did this come up, and who thought of it, and what context did they think of it in? So let's get cracking with a sort of working definition of an algorithm. So an algorithm is essentially a well-defined sequence of computational steps or computational procedures, if you wish, that kind of help to transform some value as input into some value as output. It'll be nice to go through a few simple examples of algorithms, especially ones within our daily lives. You might not have thought of the process or the procedure to make a cup of tea as actually an algorithm, but effectively it is just an algorithm. If you break out the sequence of steps, systematically in terms of what you need to do to make a cup of tea or make a cup of coffee, it's a repeatable set of, a sequence of operations that you need to conduct before you're actually able to make a cup of coffee, or perhaps even to make a sandwich. Different procedures might be required to make different types of sandwiches, but if you can decompose it into a sequence of steps, it's effectively an algorithm. If you had a sort of a list of numbers, and you were to say, find me the largest number within this list of numbers, you would effectively need to invoke an algorithm. If you had a list of numbers and you said calculate the average, again, you are effectively invoking an algorithm. Now you can think of other examples as well. So for example, if you were aiming to visit a friend somewhere in some other part of the city, or if you wanted to go for a movie in a movie theater, then the route that you are actually choosing, the path that you're trying to find, a certain optimal path that you're trying to find to get from where you are to where you want to be. The destination could be meeting a friend, the destination could be attending a movie. Then that path finding process also actually happens to be an algorithm. So suddenly when you look around us, you look at the world around us, then just suddenly it starts looking as if we are all acting in a very, very sort of algorithmic manner, and there seem to be algorithms all around us. Now, what are some sort of desirable characteristics of an algorithm? Let's highlight 5 desirable characteristics. One is that it needs to have an input. So, it must have one or more inputs, which are the values or the variables that are used by the algorithm to produce a desired output. The second characteristic is output. So, one or more outputs which are the result of the underlying algorithm's operations. The third is that it should really be well defined. Essentially what that means is that all the steps or the operations should be very clearly defined. They should be easy to understand, and there should be no ambiguity or no confusion. Fourth is that it should be finite. It really must finish after a finite number of steps. Essentially what it's saying is that it shouldn't really be just going on forever or actually get stuck in a loop. And the fifth would be effective, which is essentially saying, it should be practical. So it should solve the problem that was designed to be solved in a reasonable amount of time. Let me outline what I think is a good working strategy when you're aiming to work with algorithms. The strategy has 3 parts. Part 1 is just get an algorithm which does the job and start with it. Don't worry about whether it's a great algorithm. Don't worry about even if you know that it's actually a very bad algorithm, as long as it does the job. Just start with it. Now, coming back to the example that I gave earlier, with making a cup of tea, I'm sure a lot of us did not get that algorithm right the very first time we tried it. We did something, we iterated on that algorithm, and then probably eventually converged on something we were happy with. So in a similar way, when you're actually working with algorithms that you're implementing, just start with something that works. Doesn't matter even if you know it's not a very good algorithm. Stage 2 would be actually ask the question, can we do better? Can we make this algorithm better? And stage 3 would then be, hang on, can we eventually work towards an optimal algorithm? So if you have this 3-stage process at the back of your mind, I think that turns out to be a fairly good strategy, especially in the early days of learning algorithms. But what I find is that a lot of people tend, especially even in the early days of learning algorithms, wanting to find a very good algorithm to begin with. Now, that happens with time. It takes time whereby your initial guess or your initial approach rather is actually a pretty good one. Just start with something simple which works, and don't worry about the fact that it may not be great as long as it does the job. So I'm just going to end with sort of one line encapsulating the sort of philosophy that a working algorithm in practice is actually far better than a potentially great algorithm in your mind.